Over the years, we have seen different ways to work with databases in Java, each one solving problems and making things easier than before. In this lesson, we'll dive into the key technologies that have shaped how we access data and how they all come together in Spring Boot. Let's start with JDBC. JDBC stands for Java Database Connectivity, and it's the standard API for interacting with databases in Java. It allows our Java code to execute SQL queries directly and retrieve results. Using JDBC, we have to manually manage everything. We have to open database connections, prepare SQL statements, execute them, and close connections. Here's an example. In this example, first we are creating a connection, then we have a SQL statement. We have to prepare it, execute it, read the result, and when we are done, we have to remember to close the result set and the connection. If we miss any of these steps, we're going to run into issues. That's the problem with JDBC. It's very powerful. It gives us full control over database access, but it comes with a cost. We have to write a lot of boilerplate code just to perform simple operations. That's where JPA comes in. JPA stands for Jakarta Persistence API. It was previously called Java Persistence API, and it's a specification for mapping Java objects to database tables. With JPA, we don't write raw SQL queries for common operations like saving or retrieving data. Instead, we work directly with Java objects. Here's an example. Let's say we have a user class that is annotated with the entity annotation. With this, we can save a user to the database with just a few lines of code. We simply call entitymanager.persistUser. As you can see, JPA significantly reduces boilerplate code. It provides a cleaner, object-oriented way to interact with our database. Now, as I said, JPA is just a specification, meaning it doesn't provide an actual implementation. So this entity manager here is just an interface. It doesn't have a code. Now, to use JPA, we have to use one of its implementations. There are many implementations available. Hibernate is the most popular one, but we also have OpenJPA, Eclipse Link, and so on. So Hibernate is a JPA implementation and what we call an object relational mapping framework. If you're familiar with .NET, it's similar to Entity Framework. So with Hibernate, we don't have to write raw SQL statements anymore. Hibernate takes care of generating SQL statements for us, such as for inserting, updating, or querying data. But Hibernate also extends JPA and gives us additional features like caching. It reduces database queries by caching results. It also has a powerful query language for advanced operations. It's called Hibernate Query Language. It also gives us automatic schema generation. So it can generate our database tables based on our entity classes. So JPA and Hibernate are great, but we still have to write a lot of repetitive code for common operations and things like pagination, auditing, and other common features. This is where Spring Data JPA comes in. Spring Data JPA is one of the Spring projects and builds on top of JPA and Hibernate to further simplify database access in Spring applications. It gives us repository interfaces for performing common operations. For example, to retrieve or save users, all we have to do is to code the user repository interface like this. With this, we can focus on the business logic and let Spring Data JPA handle the database interactions. So let's quickly recap. JDBC, JPA, and Hibernate form the foundation of database access in Java applications. JDBC provides low-level access, JPA simplifies it with an object-oriented approach, and Hibernate enhances it further as a JPA implementation. Finally, Spring Data JPA takes it to the next level, letting us work with repository interfaces for even simpler database access. Now that you have an understanding of various database access technologies in Java, next we're going to set up our database and get started.